The client server and end-tiered architecture pattern is a really core principle, especially on the web for building big applications. Now, to some degree, we can say the client server application is a n-tiered architecture where n is equal to 2. But it's still useful to talk about it to be able to introduce the notion of this. So, um, big applications with a lot of single code are really easy to build, much easier than things that have to go online and deal with multiple users. But they're particularly limited. A single application has a single user interface. All the data is in one place. It's much easier to manage that. I mean, a single player video game is much easier to build than an online video game. A single application where the teacher keeps a spreadsheet for grades is much easier than letting everybody see their grades in real time. But again, that application is only useful in one place. So it becomes really obvious that a single tiered application doesn't really serve the modern internet age of what people want from their software. And so we want remote communications in software. Now, one way we can do that is we can have a single application and allow people to just call into it. You can just call your teacher and say, hey, what's up? But that's limited as well because the teacher can only talk to one client at a time. So when we say client server, we're really wanting to talk many clients and a single server. We want to have this idea of this remote shared resources, not just simply one person uses an application remotely, but that the interfaces are customized to that user, but the back-end logic and data are shared across everybody, just like a Zoom meeting would be. Everybody can see each other, everybody can see the data, but everybody has their own device in which what they're watching the machine, the presentation, the meeting. So the idea behind client server is I have a server, and then I have all these different devices that log in. They don't have to be laptops. That could be any device there, but it just shows the difference between the big honking server and the quote unquote smaller devices that access it. They could be big devices though. You could have big servers talking to big servers. So this approach of client servers is saying I have one tier of server that is the source of data, and then I have all these different clients. Now, those clients could be web clients. Like clients could be GUI applications that talk over the internet. It could be mobile applications. It could be there could be many different clients out there based off the software. You could have an Apple client, an iPhone client, an Android client, a Windows client. The idea of having multiple clients and multiple different software doesn't change this, but the architecture is saying there's two tiers. Um, the clients do tend to vary. There are such things called a thick and a thin client. A thin client generally is saying it's just a user interface, and that's what you're thinking mostly in your traditional website. I just have a screen. Every button I press gets sent back to the server, and the server shows me what's going to show up next. A thick client is a traditional, Windows or Mac GUI application that has some logic inside of it and only calls back to the server for very specific data requests or very specific shared behaviors. So again, like if you're playing a video game that's an online video game, most of your stuff is going to happen locally. It just talks about when you're, opening a chest or attacking a bad guy or whatever the video game does. That's when you talk back to the server, when it's a shared environment. Either way, these can work because now in these days, even websites often have quite thick clients. There's a lot of logic that happens on your computer because the smarter the client is, the more responsive it is to the user, and the less demands it is on the server. For if I got a million people out there doing very simple stuff, that's still a lot of demands that's asking for you. The more you can have the clients do themselves, the easier it is on your servers. But it also adds to the work of the client team to have to build that out. But it does leave the question, when I have this client server architecture, do I really have one server that's going to do everything we need to do? It's going to provide data and give behavior and do security and all these different things. And we know that's possible, but it also can be very problematic because like the client servers, the client interface with the server, but often that server doesn't have to do all the work itself. So, if I drive up to the drive-through window, I can order food, but the people giving me my food are not the people cooking the food. The people cooking the food are not the people growing the food. So there's this the idea of an n-tiered architecture is I'm separating perhaps the user interface from the core logic, from the data storage or the data creation or other different features. And again, in a kitchen, I might have several tiers of chefs. I might have sous chefs that are preparing ingredients that other chefs use to cook and prepare the final meal. Again, food analogies, a lot of them. But in software, what I might have is I might have a user interface that calls a service that then might call another service. So I might want to say, I have an online shopping service, and you're going to buy something. Well, I'm not going to process the credit card myself. I'm going to call another service to be able to pay that, go process, run that credit card that I've been given and be able to pay for the service or the product. And that's the idea of an n-tiered architecture is I have services that call services, and I don't have to have the client be aware of all the services, and I don't have to have all the services be done in one location. So your typical n-tiered architecture is going to be often web browsers up front, could be thicker clients, but these days mostly web browsers or mobile apps. Your big server in the front and the database in the back end. We separate out the data in the back end, so there can be, and that's really really important because that allows for scalability of the number of users that are getting done. If I have 100 users using a system, I can have a single server. If I have 1,000, I'm kind of stressing that server. If I have 10,000, I probably want a couple servers. If I have 100,000, I want a whole truckload of servers. But I still need that shared data in the back end. And people need to work on the exact same data sometimes. So that's why n-tiered is great because I can have little bits of the work shared across multiple servers, and they might be all doing the exact same thing, but you're talking to different people. Think of it like going to the grocery store. There's not a single line to check out. There's a bunch of lines. Well, those are all people doing the exact same thing, but they can service more than one person at a time. But they all need shared data, which is how much each food item costs. So the idea behind client server and n-tiered is to identify uh, the users and the shared resources that the users need. Okay. And when they have shared resources, I want to make them available by creating a system that splits across those functional needs. What are the things that users are going to share? What can they use on their own? And then give them the local resources they can work with, and ideally create an application that deals with those local, or at least logic that deals with those local resources to give the most responsiveness and the most behavior without being dependent on whether the internet's working or those other forms of communication. And then as you're building your system, moving from client server to end tier, I want to delegate the work to the system that's most appropriate to do that work. It speeds up the system. It allows better control of data and behavior because I can have that all happen in one place. And it also makes my application more scalable. I can have more users use it at the same time. So architectural patterns are partially about making software more functional, easier to write and use, but it's also about making it easier to deploy and be able to service more people using the same logic, but just putting it on more boxes, more places, a bigger cloud, if you will, and then letting more people get access to it.